Ever wonder how a robot could truly grasp a command like, grab the sponge from the top drawer and put it on the counter? Most AI systems today treat vision, language, and actions as isolated puzzle pieces, hard to connect. But what if we could teach robots to think like humans, weaving together perception, instruction, and action? That's exactly what the UniVLA model is achieving, and it's rewriting the rules of robotic intelligence. Let's dive into the breakthrough. Traditional robotic AI splits tasks into two stages. A vision encoder processes images, and a separate system generates actions. But this siloed approach misses the bigger picture. Real-world tasks demand more than just seeing or moving. They require temporal reasoning, causal understanding, and contextual awareness. UniVLA solves this by treating vision, language, and actions as discrete tokens, like building blocks in a unified language. Imagine training a model on videos where it learns not just object appearances, but how they move, how language describes their interactions, and how actions shape the environment. This unified framework enables the model to tackle complex tasks. Spatial reasoning, where's the fork? Visual prediction, what happens next? And policy learning, how to execute multi-step tasks. Here's the technical core. UniVLA uses an autoregressive architecture, similar to language models that generate sentences. But instead of words, it sequences visual frames, text instructions, and action commands into a continuous flow. Think of it as teaching a robot to think in movies, where each frame, each word, and each movement is temporally linked. The results? UniVLA shattered benchmarks. On the LIBERO dataset, it achieved a 95.5% success rate, surpassing prior methods by over 10%. But it's not just about speed. The model excels at long-horizon tasks, like following chains of instructions, and adapts to real-world scenarios like robot manipulation and autonomous driving. What powers this? Temporal understanding. By training on vast video datasets, UniVLA learns causal relationships between actions and outcomes. It doesn't just recognize a sponge. It understands how picking it up affects the environment, how language guides the process, and how to adjust if things go awry. This isn't just a step forward for robotics. It's a leap toward generalist AI with embodiment. Imagine robots learning from videos like humans do, adapting to new tasks with minimal training. UniVLA is paving the way for machines that don't just follow orders, but understand them. Now let's zoom out. The big challenge in robotics has always been teaching machines to understand the visual world. Traditional robots are like trained dogs. They follow commands but struggle with surprises. This research flips the script. Instead of hard-coding every action, scientists feed robots massive video datasets, thousands of hours of real-world tasks, and let them learn patterns autonomously. It's like giving a robot a library of tutorials and letting it reverse-engineer the rules of the game. Here's the magic. These robots aren't passive viewers. They build world models, mental maps of how objects move, how actions cause changes, and how to plan solutions. For example, watching a video of someone stacking blocks, the robot predicts what happens next when a block is moved. Over time, it develops an intuitive grasp of physics and object interactions. The team leveraged datasets like RT1, Bridge V2, and Droid, which pair videos with text instructions and robot actions. Picture training a robot by showing it a cake baking video, then teaching it to associate visual cues, a whisk moving with motor commands. They even tested this on real robots, like the Aloha platform, which uses cameras on its arms to mimic human vision. But here's the kicker. These robots don't just memorize videos. They use techniques like latent action for training and 3D vision language action models to generalize. Think of it like learning to ride a bike. Once you grasp balance, you can ride any bike. If a robot hasn't seen an object, it can still manipulate it by recognizing similar patterns. The results? Unbelievable flexibility. These robots master tasks like inserting objects into slots, assembling parts, and handling messy environments, without tons of custom programming. And they do it with far less data than traditional systems, a game changer for efficiency. Why does this matter? Envision a future where robots learn from online videos the way we do, quickly, adaptively, and with minimal supervision. This could revolutionize industries from manufacturing to healthcare, turning robots into true collaborators. The next time you watch a tutorial, remember, somewhere a robot is learning alongside you. The future isn't just smart, it's curious. Stay tuned for the next leap in AI.